Good evening, everyone. Welcome to the day 3 for Android Study Jams. I hope you guys are doing the units of the Android Basics in Kotlin course. And once again, I request you all to engage more with the community and follow the units, ask doubts, make apps, form teams. So today's session, we'll be talking about how to connect your app to the internet, and in that process, we'll learn the concepts of what view models are, how to use them, what coroutines are, how to use them, and at the end of the demonstration, which my friend Shrikant would be taking, we'll create an app to fetch images and display it on your app using the coil library. So without taking much time, I would like Shrikant to start about the session.
Yeah, is my screen visible?
Yes, Shrikant, you can start.
All right. Very good evening to everyone joining us today. Today we're going to cover a very important part of Android development, which it's basically the backbone of the backbone of internet communication today is like connecting to various servers around the world, getting and retrieving and sending information back and forth across servers, devices, and therefore it only makes sense that you have the ability to make your app do this in Android development. So that's what this unit is going to be covering today. As part of this unit, we'll go over quite a few concepts that we need in order to make the end results. Before I reveal to you what our goal today is what our goal today is, I'd like to just briefly go over the topics we'll be covering today. So first of all, we'll be taking a look at view models and really telling you how we structure the interface between data sources, like where the data is retrieved from our app, whether it be a single counter or data information from a database or from the internet, and how we're supposed to link it to the user interface, right? So what the user basically sees, right? So one component handles what the user sees, that's the UI interface, and there is some data source from which we retrieve whatever we're supposed to show to the user. The interface of both, the bridge that covers both is what's known as view models in Android development. So we'll be taking a look at that. Secondly, we'll be going over coroutines. So this is where our real work starts off. This is a real building block of making HTTP requests. So now pinging a server and getting information back it takes a noticeable amount of time, right? Even on the fastest of internet connection, it'll take some time at least. So in that event, you don't really want to block the UI thread, to make the app freeze while it's doing that. So coroutines helps a smooth experience and make sure that the internet request happens smoothly and in the background. So we'll be taking a look at that. Thirdly, we'll be taking a look at how the actual HTTP request is made, how you can write the code for that in Android Studio. And finally, we'll be taking a look at how to display images over the internet. So once you've gotten the actual location of some image, you've gotten a hyperlink, right? So how we can download and display the image using a certain external libraries. So these last two concepts require external libraries. So for HTTP requests, we'll be using Retrofit, and for images, we'll be using Coil. So yeah, so these two require external libraries, but for the first two, they are inherent concepts in Android development and Kotlin, which we need to cover in slightly more detail. The end goal for today is a small app which goes to this URL, right? So this is basically nothing but a JSON API service which returns placeholder data, right? So it doesn't contain any actual data, but it returns some data in JSON form, right? So we'll be looking, so it has a separate endpoint for certain placeholder photos, right? So we'll allow the user to select a number from 1 to 10, which is the ID of the image, and we'll query this URL, and the response, and from the response we'll extract the image and display it to the user screen. Simple app, but it will help encapsulate all the concepts which we're going to demonstrate today. So without further ado, let's come to the first the first concept, which is MVVM architecture and Android development. So view models. So before we go to view, let me explain this somewhat briefly. So imagine this is a device, right? So I'll just draw here to explain. Just a minute. Yeah. So suppose this is a device, right? Uh, this screen, this interface is what the user sees. You have certain data, and no matter what app you open, you'll have some data displayed to the user, right? And this data can be derived from a variety of sources, right? It could be something available in the user's device itself. It could be something retrieved from storage, right? So, for example, if you open a contacts app, you'll have a list of contacts on your phone, right? That is stored in your phone's internal storage or SD card or wherever. So so either the data displayed on an Android device can be through the internal storage, or it can be through an external source, right? So for in our example, the internet, right? We're querying a UI, we're querying a specific URL, and from that we're getting a certain response, some information, right? So whether it's the internal storage, whether it's the internet, or whether it's some other internal cache, there is some data source in our app, right? Which is known as the model in MBVM architecture. MBVM stands for model view, and it's basically a method, a kind of structure in your code which helps interlink the model for your app, the algorithms, the basic logic for your app, and what's actually shown to the user. So you have certain data sources which you need to display to the user, right? And you probably also want user to maybe change the data sources, right? Maybe you want to post, let's say on YouTube, you want to post a comment. So we'll be changing data on the YouTube servers by sending a request that I want to change some particular data. Now, so where should we write the code for all of this? So in Android Studio, you probably have a separate code file for the UI, right? So you'll have buttons, you'll have text views, you'll have edit texts, right? So to place all that, you'll probably need some UI code. Now the question is, should we place a logic for how these UI components on the user's interface change the data, or retrieve data? Should we put that in the UI code? And there is a very good reason for not doing so, because first of all, these are two very distinct operations, right? This When you talk about UI code, this is front end stuff, right? So UI code is typically front end stuff, and its main job is to react to the user, right? So if the user clicks a button or updates some field, we wanted to keep track of that. And good programming supports encapsulation, where we clearly separate intents in different files, right? So one file is very clear what function it performs, and another file is different in what function it performs. So we typically do not want to put any app logic or data sources in the UI part of our code. So what's the solution for ensuring that these two components, the UI and the data source, interact? The answer is a view model. It serves as a bridge between these two. And so how it does it is, so yeah. So how it does it is, so this is your model, right? Yeah. This is your model. Hang on. Yeah. So this is your model, right? This is what holds your data, what you want to present to the user. It's some representation of that. So what the view model does is it keeps track of both. It remains in connect with the UI source. This is what is shown to the user, right? The UI components and such. This is the data, and view model keeps kind of a connect. Something is done about it, right? Like when you press a button, some action is performed. So the view model is notified by the view part of the architecture that some event has happened on the user screen, right? It passes user events, and it can also observe data changes, right? So let us say there's a slider, right? typically on changing some value, let's say the brightness of the screen, you have a slider which helps the user control it, right? So that's a data change which the user is capable of changing directly through the UI component. It's an example using a slider. So you also want the data change to register, right? That some data displayed on the UI component has changed, right? And the view model is passed this information. Now the view model is now responsible for passing on the events or changes to the model, right? So let's go back to the brightness example. If the user wants to change the brightness of his screen and has interacted with the UI component, then obviously we want to notify some other background service, system service for the app, which is in charge of handling the phone's brightness and other system settings like that. So uh, it is responsible for passing data and then getting the results, right? So in the event of brightness, or let's say in the event of an internet request, right, we'll get some response back from the model, right? It's like input in, which is the user's interaction, and output out, which is the result of whatever the logic stored in the model. And then the view model is communicated back to the view and makes some changes to the data, make some changes to the data stored in the displayed in the UI if needed. So this is how the view model. So see how we have compartmentalized the three different functions of Android functions, right? This is solely in charge of UI, yeah, and UI interaction and change. This is solely responsible for the app logic of your app, right? What you want the app to do, and to make sure that these two are connected and correspond well with each other, we have the view model. So yeah, this is basically what I said. So model represents your data sources. It's an abstract action of the model, action of the data sources. The view informs the view model if any actions take place, as I explained before, and the view model connects connects the model and the view in order to keep the app's logic running seamlessly. So to take an example, this is so in Android we have something called activities and fragments, right? So the view model helps communicate the user interface with the data source, which could come from a web service or an internal database, and using something called live data, which I'll come to in a minute. It communicates changes to and from the user interface. So now what are the advantages of using view models, right? So uh, first of all, as I told you before, it abstracts the data separately from the UI logic, right? We Otherwise files which contain both UI logic and the logic for and the basic underlying logic for that can get very bloated. So it separates the two, so it's easier to handle and debug. It survives configuration changes. So whenever you rotate your phone, the user interface is destroyed, right? Because now whenever you rotate your phone, you expect obviously different layout. So it has to reconstruct the activity from scratch. So whatever data is displayed is essentially, if you don't keep a copy of it somewhere else, it gets destroyed and it's reconstructed based on initial values. So view models help the data survive changes like that, and um, data changes like that, and yeah, and help how the data persists even if the UI configuration changes slightly. So now how is data exposed to the user? So what's the connection between my underlying data and what is shown to the user? The answer is live data. So what this does is that this helps with that to and fro communication I was talking about earlier, between the UI logic and the underlying logic. Right? It reacts to changes in the data stored, and we don't need to explicitly tell the UI that did some data underlying data changes happened, and you need to update it to the user. Right? It automatically happens using observers and live data classes. So before I continue on to core routines and background threads, let us start with the code demonstration for view models without wasting any further time. So I'll open Android Studio. I'll just check if we have any questions so far. Okay, none for the moment. So I won't be so. This has been covered in the in previous session, in previous study jams, how to create and initialize new project. So I just need to want to draw your attention to the fact that we'll be starting off with the fragment and view model class, right? So we don't need to create the classes and files from scratch. We'll have that initialized for us by Android Studio, and yeah, that will just be easier all in all. So I'm just gonna rush through this since this might have already been covered. So yeah, this might take a while. And yeah, we I think we're done. So this is a view model, right? So we'll before we come to what the view model does, I'll quickly design a base a simple layout so that we can start interacting and changing underlying data. So since it's already been covered in study, then I'll just kind of rush through this quickly because I just want to demonstrate something else. So we'll maybe get rid of that and we'll add text view to buttons and yeah, three buttons actually you need. So we'll add some space between the components just so it looks slightly nicer. We'll add 16 here, 16. Yeah, we'll and uh yeah, so we'll for the moment we won't have anything written here, uh just for preview we'll have it here. And we'll change the buttons just a minute. So for the moment, we'll have a text view here, and so this is a basic user interface. It doesn't look very good, but it'll do for the moment. So we have two buttons here from with which we'd like to change this data which we are displaying here, and when you click this button, we like this data to change, right? So maybe we for like our end goal is to have an image view here, which changes based on what of the idea of the image the user wants to see. For the moment, we put it as a text view. It's for demonstrating. Um, uh, just change the constraints a bit. It looks nice for the moment. Yeah. So now let's quickly implement the view model. Before that, actually, let's just implement data binding as shown as previously demonstrated in the previous study jams. So we'll quickly do that. We right click here and say convert to, hang on, wait a minute. Yeah, sorry. To implement data binding, you first need to go to Gradle and set data binding equals to true. That should be, hang on. By the way, if you need to look something up, don't hesitate to. Sometimes even the most experienced programmers need to look up certain in case they forget. Uh, we need to change a certain setting in certain feature in Gradle to for this to be true, and yep, that should be enough. And this. So yeah, now we can convert it to data binding layout, we'll, and for this we'll add the view model, right? So in data binding we add certain variables, right? So that they can directly talk to the UI. So in this case we'll be just passing the view model to the as variable, because it'll store all the data which we intend to present to the user. So yeah, that's it. So now to implement the functions of view model, actually hang on, first again we need to uh, change the binding settings here. So yeah, so that's just some boilerplate code in order to set data binding in our app. And now we'll set the variables for data binding, which is our view model, right? So that's that. And I'm adding an extra line here, which I'll explain in a while why it's necessary. So we're setting the lifecycle owner, which kind of monitors whether the activity, whether the user has opened the fragment or closed it, or just destroyed it by swiping it out of the recent apps list. So we're setting it to this particular fragment, and I'll explain why in a minute. But first, now let us quickly set up the variables we need for our view model. So the one thing we need to store is this particular number, right? So what at the moment what we're doing is nothing but changing the this is supposed to be just a normal counter, which we can change using prev and next buttons, right? So we'll need uh, so you do that using using the class called mutable live data and live data classes. So if we'll initially set it to 1, right? And we'll keep it as a private variable, because this is not exactly what we'll be exposing to the UI component. What we'll actually be exposing will be the live data will be a live data class, which once initialized cannot exactly be changed. We'll change it indirectly using the mutable live data object, which will be handled primarily by the view model. So as I said before, only the view model is in charge of changing handling changes to the data and communicating it to the UI, and vice versa. So if so yeah, we'll just set it to this, and yeah. So we got set up the actual variable. Now we need functions in order to change this variable, right? So in this case, we've got these two buttons, right? When this UI interaction happens, we'd like it to change this particular value. So we'll quickly create two functions. So actually, yeah, we'll need two functions, at two pieces of data here, because we're also changing this particular text view. So we'll call that response for now, because later we'll use it to store our the response we get when we may move on to HTTP requests. So yeah, I think that's so for the moment. This is all our app logic, right? So this represents the data we're observing in the UI component, right? So we've got a certain value which the user is selecting and some other pieces of data which is dependent on what the user is selecting here. This is simple. This is a simple app logic which we're storing in the view model here. So now, how do we actually link it to the UI component? So earlier we set the data binding variable here to the view model over here, the main view model here. So now we set this variable. We can now use the date. We can now use the data directly. Use the variables here and the logic here, and connect it to our UI interface. So here we'll set it to. So here I've set this to current, and in this text view I'll set it to the other data source, which is the view model keeps track of. Yeah, we so for the buttons here we've used lambdas to indicate what function it has. So when the user clicks on any of these buttons, uh, uh, the logic for what should happen behind the scenes is all contained inside this view model, right? So it just says whatever happens. So the way we have so the way we've modified our XML file, it just says what if any interaction happens, the and whatever data you need to retrieve, everything is contained within this particular view model. So I'll just quickly see that the layout doesn't get messed up before I run it on my emulator. Just a minute. So we'll make this a little bigger just so that it stands out. We'll change this to, let's say, 24 SP. Yep, that should do. Really doesn't look that great, but yeah, this is just for demonstrations. Hang on. Yeah, so I think that's taken care of. So we now will just run this on the emulator just to see if everything's working perfectly as we intend. Hang on. We'll just check if there's any new questions. No, not for the moment. Some issue. Hang on. Just a minute. Okay, so there's some issue there. So in the meantime, we'll move on to the next part of what I wanted to explain today. We'll go ahead with coroutines and HTTP requests for now. Yeah. So now we looked at how we looked at how data data can be influenced and transmitted back and forth between a data source and and a UI using a view model. Now we'll come to something called coroutines. So typically on devices and in processes, we come across we often need to multitask, right? We need to run multiple sections of code at once, or multiple sections of code at once, so that it doesn't block the main thread. So for example, let us say I need to make a network request. So the user is interacting with the app, and I need to get some information from the internet to display to the user. So yeah, so while the user is interacting with the UI, in the background, the device also has to perform a certain request to maybe a server or some other source of information and get that response back. So that takes time. And in the meantime, we don't want the user to stop interacting with the app, right? Maybe he wants to look at some other information which is already present on the screen, right? So we don't want to keep him waiting just for to make this just to make this to make a network request, right? Otherwise, it will be a really laggy experience for the user, and it will not be a very great experience. So we introduce something called multitasking, where we in the background thread, on the background code snippet, we carry out network carry out whatever background work we need to, while the UI thread continues to manage interactions and other use whatever the user needs to see. So the building blocks for this are threads in an app, right? So the each of these handle various functions, right? So maybe one of them handle the maybe one of so maybe one of them handle the UI experience for the user, right? It responds to user interactions or whatever. This maybe one more handles the background data work, right? It retrieves data from the internal storage and displays it to the user, formats it. Maybe another handles network request. So each thread has a different function in the apps, and they all run within a single process, which is an Android app. So now you might think, why don't we just initialize more and more threads, as we need more background work to be done. Now the problem with that is each thread is extremely heavy, right? So it requires resources to start up a new thread, give it a job to do, and initialize it. Right? It requires memory, and in your phone, memory is a limited commodity. So you need to know how to, as a developer, you need to know how to handle it carefully. Second is the unpredictability. Sometimes you might not have control over when the thread will execute, and at what time it will be interrupted, because threads are typically handled by the processor's preemptive scheduling. So again, that's a factor of unpredictability you really don't have control over. So Kotlin has a concept, among other languages, has a concept called coroutines. So how are they better than threads? So first of all, if you go to Android documentation, you'll typically see coroutines referred to as lightweight threads, right? Like threads, basically like threads, but with less resources. But the difference is that you can run many coroutines on a single thread, right? You maybe conduct multiple operations, maybe multiple network requests you need to be made, and so you don't need to create a thread for each one of them. You can just create multiple coroutines on a single thread, right? Which maybe is reserved just for that particular purpose, to make network requests. So you can have multiple coroutines queued in a thread. The third advantage is something called cooperative multitasking, right? And this prevents, again, lag blocking of threads, which can really hamper user experience. So how does this work? Let's say you have two functions, function A and function B. they each need to execute. Now, how cooperative multitasking works is that they each stop and start based on different points on what needs to be done, and let the other function take over, right? And uh, and they do this without blocking the execution of the thread, because when one function stops, the other takes over, right? So similarly, in coroutines, even if a coroutine even if a coroutine performs an operation which is taking some time, maybe you have a weak network connection and you need to make a network request. So while this is happening, this thread doesn't necessarily need to be blocked, right? It can continue with whatever other work it has to do. But when the request is finally complete, it jumps back, gets whatever information, and then carries on, right? This is what the thread base. This is what coroutines help us to do. So without without putting a stop to things on the operations of a thread, we can conduct multiple background tasks needed for the app. So now, how do coroutines actually work? So now coroutines, there are some particular objects which it requires for it to execute properly. So first, it needs something called a coroutine context. So what this does is, a coroutine context is basically an object that has a set of rules, right? It's a set of rules which executes the coroutine, right? So it takes care of where the coroutine should be started, how long it should run, right? Should be cancelled, stuff like that. Inside the context, you have different units which each perform a separate function in the coroutine. So first one is something called a job. So the job is the actual unit of work which you perform in a coroutine, right? So in this code snippet, you can see here that this is defined as the job. So the job is whatever you actually want to do, that unit of work, right, which can be cancelled at any point, right? If you assign something to coroutine, you the job ensures that it can be cancelled at any point in time if it's so desired, right? Then you have something called a dispatcher. Now I said earlier that you can have multiple coroutines running on a single thread, right? So maybe some the dispatcher helps regulate the thread on which you want to run the specific coroutines, right? So maybe you don't want to run the coroutine on the main thread, because that will block, because on the main thread, because that's handling your UI, right? You don't really want network request to run on the UI thread. So you maybe run on the thread which is responsible for input output operations. So the dispatcher helps you do that. It helps you specify the thread on which you want to start the particular coroutine. Then you have something called a scope. So again, the scope actually defines the life cycle for the coroutine. So the scope and job go hand in hand, because the scope defines when the job needs to be cancelled, right? So typically in Android, there's something called a view model scope. So whenever the view model, till the point in time in which the view model exists, it makes sense for it may it makes sense for the coroutines the defined in that particular scope to do whatever work it's assigned. But let's say the user exits the app, right? So let's say let's say this is the UI interface which the view model is connected to. And and in the view model, you have a specific background task which is being performed using coroutines. But now let's say the user closes this particular screen or app, right? Then it doesn't really make sense for this to continue. So for the operation to continue, right? Because there's no interface to return the results to and display to the user, because you already closed it. So the scope keeps track of all this and defines till which point the coroutine can run. So much for coroutines and background threads. So let me give another try to this emulator, see if it's working. If it does, then we can move on to the next part of the we can move on to the next part of coroutines. I'll just check quickly if there are any questions. There don't seem to be any, so I'll just carry on. So there seems to be a crash. Hang on. Okay, so uh, oh, hang on, stupid type. It's typo. We don't actually need to redefine the variable. We can just same thing, and now it should give no more issues. So yeah, this is so you'll run into small bugs like this uh, while coding in Android Studio. So you just need to be a little alert to catch them using the log cat errors. Oops, another crash. Slight hitch. Let's see if we can fix it. Yeah, sorry. So I needed to initialize my variable here as well. So that was another error I made. Hang on. Hang on, I'll just. Okay, small hitch. I'll just fix it and get back to you. All right, so we've run into a slight hitch. So I'll just carry on to the next topic, which is to make HTTP requests. Uh, so we'll just go for that now, and then come back and have another crack at this. Yeah. So I left off at core routines. So now let's get to the actual HTTP request part, right? So in our use case app, what we're trying to do is we're querying a particular web server, right, and we're receiving a response back from the server, right? So we're querying the URL for some placeholder images, and we're getting back some response. So what's the architecture for this to happen? So now there's something called a restful architecture, which is a representational state transfer architecture, which helps this happen. So how does it work? So let us so let's explain. So let's say this is a device, right? This is what wants to communicate with the server, and you have a server somewhere which has certain resources inside of it. Now these resources are stored at addresses. So similar to how you have house addresses which identify where a particular group of people live. Here, data have certain addresses known as URIs, right? So this is what identifies the data. So if you want some particular piece of data from a server, you have to identify its location in the server, right? So to give a somewhat crude example, on YouTube, when you want to view a video, you go you wa- you initialize with a certain parameter called watch slash v is equal to and a random base 64 number, right? So that identifies where that video is stored in the YouTube servers, and it helps it, and your browser sends that request, and it returns with uh, and it returns with the video information, which is then displayed on your device. So this is how data is stored on servers. Now how do we request that we want to retrieve this data, or we want to change this data, or perhaps even add new data to the server? So the request essentially contains two parts. So first of all, you have the HTTP particular method, right? You have the method which defines the operation you want to do with the server data, right? So for example, in HTTP, we have defined that if you want to retrieve data, we use a get request. If you want to add data, so a get request might entail seeing someone's comments, right, or seeing, let's say, the number of likes your video got on YouTube. So all this requires retrieving data, and that's performed by get request. A post request adds new data to the server, right? So when you maybe upload a new photo, that might be a post request because it's adding new media to the server. And a put request updates any data you have. So let's say you want to you have a blog post which you want to edit. You maybe found a typo there, so that might be a put request. So now, and then of course second part is the URI, actually the actual location, right? So if you want to retrieve data, you have to specify the actual location where the data is stored, right? Or if you want to update it, you have to identify where that existing data is stored so that it can update it. Now the server receives a request. How does it respond to you? So it sends you a representation of the data, right? And typically most servers around the world use forms like XML, right? XML or JSON. These are standard forms of communicating data to and fro different types of devices, right? Or different forms of data. All of this is standardized. This transfer of different types of data between different devices is standardized in a representation, which is typically XML or JSON. So if I want to show you an example, so we talked about URL. So if I quickly uh, open this URL, this is this is a this is essentially a get request we're performing, right? Whenever you type something in the address bar, our browser typically performs a get request, which because it wants to retrieve some data. So in a particular use case, if we just type photos as an API endpoint, right? This is the URI, right? Because all this data is stored at this particular location, and it's returned as a JSON array, right? And the image is given certain album IDs, a title, and a URL, right? Uh, so the actual image is maybe stored else in some other URL, a completely different URL, but the our request returns this URL, right? So the list of images that uh, this API has is represented in a JSON form. So much for this. Now how does Android achieve this? So we need an external library for this, which is retrofit. We're using retrofit in our case, which does all this hard work for us, right? It specifies the get verb and the URI for us. We just need to provide you the bare essentials, and all the underlying metal work is performed by the external library, which is why they are so useful in Android, because typically Android developers do not want to associate themselves with all the hard work underlying this thing. So retrofit, given just the base URL and endpoint, performs the request, and it then returns the response. It returns the response in the particular format, right? So it's simple input in, data in, data out, right? The library performs all the required functions, the required metal work required for the HTTP request, and we need to provide with the essential information. Lastly, we'll see how to perform display. We'll see how to display images from the internet. Right. So now that we've gotten this information, right? So in our example, we've gotten this URL. Now, how do we, yeah, this URL. How do we present it from the present it to the user? So now if I go to this URL, for instance, it provides a simple placeholder image, nice and simple. Now this might seem simple, but in Android development, there are a few steps which are required to get this image from wherever it's from wherever it is right now into a visible format on the user's device. Then you need to download it, you need to cache it internally, and then decode it into some sort of usable format. And we have another library to do all of that, right? Because these operations can vary depending on the format of the file and size of it and things like that. So you have another internal library which handles all of this for you. Again, since this is a library, it requires just the instance information, the actual URL which you need, and the image view, right? Which is the actual the UI component which you want to set to the URL, right? So on the user's device, you have some uh, on the user's device you have a UI view, right, which you want to display to the user, right? And so you need that image view object and the URL of the image to for this internet imaging to work. So it all does all this using a function called right? Right? So in this code snippet, we have a specified image URL, which it looks looks very similar to the URL I had just now, and it loads it into the particular image view object, right? And with just one or two lines of code, it performs all these difficult steps are required to download images from the internet and show it to the user's device. And what's more, Koi also allows us to set placeholder and error images. So as I mentioned before, like making a request for an app, so it will go through the same. It will make a request for the image. It will receive it in a bitstream format, and that takes time. So Until then, you want to show the user this loading image to know that the request is ongoing, or you want to show an error in case the request did not end well, or there was some other issue. So you can also specify that. So these two external libraries make it really easy to perform these two essential functions in Android, and yeah, without any particular hassle. So I reg- I'm sorry about this error here. So it kind of derailed what I had in
Thank you,
mind today.
Shrikant, for the demonstration. So I guess you can stop with the presentation for
Yeah,
now. Mm, the screen. So yeah, we saw an overview for the unit related to connected to internet. So it's 5th of January already, and we are nearing to the conclusion of the session, the anniversary jam. I understand because of our comprehensive examination, all of us started working on those units late, like all the participants from our campus. But please try to finish all the units before 10th if you want to get the advantage of the AAD certification reimbursement. Reiterating that, and 30th January is the last date to for the certificate of completion. So please let us know if you want an interactive session for asking doubts, and anything else right now if you want to ask in comments, or of course our Discord server. Since there are no comments right now, we'll conclude the session over here. Please join the Discord community, ask your doubts, share whatever things you're doing over there, and interact in general. Thank you.